analysis using data from matching markets. As Al and Parag elaborated, there's a large literature studying various mechanisms, and this literature studies this primarily from a theoretical perspective, in which we compare various mechanisms based on efficiency, fairness, incentives, and stability. And this literature has resulted in many debates on the best forms of market organization. For example, Parag mentioned some trade-offs between the immediate acceptance algorithm versus the deferred acceptance algorithm. There are some trade-offs that have been identified here by these two papers that I've cited, and there's some work to be done in quantifying those trade-offs. Similarly, there are debates about centralized versus decentralized assignment systems and the effects of centralized systems on other things that you might care about, for example, salaries in the case of the medical match. One of the things that we've learned through this investigation is that theory does not always result in unambiguous answers. And in these cases, there's a role for empirical work that is based on estimates of preferences of agents in these markets to make some progress. And the reason why preferences, I think, are important in this investigation is that the theory really takes these preferences as primitives, and the outcomes are ultimately mediated through the assignment system via these preferences to result in a final assignment. In fact, practical designs, as Al and Parag pointed out, often use stated reports of agents' preferences to determine final allocations. And additionally, from a research perspective, these formal mechanisms result in and generate rich administrative data often on stated preferences of agents as well as outcomes. And so they are a fruitful ground for empirical work. So what do I see as empirical work doing in this field? On the first, just outright, you could engage in a variety of positive analyses. For example, you might be interested in quantifying the determinants of parents' preferences for various schools or colleges, what they value more or less. This can be important from an achievement perspective. In the labor economics literature, we are often interested in quantifying the value for various job amenities because they result in compensating differentials. And you might also be interested in analyzing the effects of variety of policy interventions such as taxes, college tuitions, subsidies, quotas on the final allocations, on the distribution of outcomes, as well as equality of access. In this type of investigation, preference estimates can facilitate general equilibrium analysis, particularly when you do not have random assignment of various types of market institutions or taxes across various markets of similar type. Now, since you're going to ultimately estimate preferences to engage in this analysis, you can also engage in normative analysis, understanding the welfare consequences as well as from a distributional perspective of these various policies or mechanisms. So in this frame, the investigation is highly complementary to the theory in the evaluation of the trade-offs, providing a quantitative counterpart to the economic forces that have been identified by theory. And it can, in some cases, also result in analysis where theory has proved intractable or has resulted in ambiguous answers. So you're probably most familiar with the revealed preference approach in the investigation of consumer choice. There we are comfortable assuming that an agent who goes and buys a particular box of cereal has bought the one that gives him the highest indirect utility as compared to all the other boxes of cereal that were available at the prices that they were posted at in the grocery store. However, as Al pointed out, in a matching market, you cannot choose your most preferred option. You must also be chosen from the other side of the market. You just cannot decide to enroll at MIT. Your partner needs to agree to marry you, hopefully. And in peer-to-peer platforms, you also require mutual consent on both sides that are engaging in a transaction. So this becomes a little bit complicated in matching markets. And what I would like to suggest is that the rules of the marketplaces, the various rules that you've been exposed to today, are going to determine how you interpret the data in order to engage in this revealed preference approach. So you need to be cognizant of the fact that a student might not apply to Harvard, MIT, or Stanford because the student might think that it's very unlikely that they're going to get in instead of a revealed preference for not liking one of these schools. So by thinking about these incentives and the rules and how they translate into the decisions that agents should be making, you might be able to make progress and analyze the preferences of agents in these settings. And in fact, organized marketplaces, I would say, present a unique opportunity for doing this because of the administrative data that is often available on outcomes or submitted rankings. And additionally, the well-understood rules of the marketplaces can assist in the various modeling choices that you could be making. Now, I'm going to talk about mostly such organized marketplaces today, and this is going to be at the cost of a significant body of related work in labor markets, in labor and marriage markets that use these similar equilibrium concepts and transferable utility models to study decentralized markets. So there are some papers that I've cited here that if you're interested in analyzing those cases, you should take a look at. So let me briefly outline the preference model and give you a quick primer on the standard discrete choice case, because I'll be coming back to the principles that we use to analyze the standard discrete choice model when I discuss the analysis of rank order data, this is typically the school choice case, and then I'll go on to a more limited data environment in which you do not observe the stated rankings of various schooling options, but look at only the case where you have data on the final matches of who got what job. So let me tell you a little bit about the preference model that we're typically interested in. This literature has usually modeled the indirect utility of an agent, agent I over possible options J. This could be a student I who has a preference for various jobs or for various colleges, or a worker that has preferences for various jobs, in terms of certain observable characteristics here given by Xij that might vary based on only the student or only the job, or only the college, or both. A preference for these various characteristics, beta I, these are going to be random coefficients typically with some parametric form, an unobserved quality of the job or the college, and idiosyncratic preferences epsilon ij. And this is a particular parametric form, but for various purposes you might want to change this, and it could be made more flexible. In this model, it is without loss to normalize the utility of a reference good, usually what we call the outside option, to 0. And since utilities are only defined up to positive affine transformations, the scale of the utility also requires a normalization. So you need to do this for some characteristic. So we'll typically be making parametric assumptions in order to assist estimation, although there are some non-parametric identification results here. So let's think about the standard discrete choice model, which I hope you're familiar with, but it'll help you frame the way in which I think about analyzing these problems. So here I've got a picture of a two-good case. On the horizontal axis, I've got the utility of option 1, V1, and on the vertical axis, I've got the utility of option 2, V2. Let's say you see an agent who picked option 1. This indicates, since this agent got his most preferred choice, since we're in the standard discrete choice case, that V1 is larger than V2, and that V1 is positive. V1 is positive because otherwise this agent wouldn't have chosen option 1 and would have not picked anything. So what we do here is to look at the option that the agent picked, and then figure out which region in utility space does this choice correspond to. And in this case, with two options and the possibility of not picking anything, there are 3 regions in utility space. This gives you, as a function of the parameters, a likelihood or a choice probability, and other forms of empirical information that maps the model to the data. And sure enough, there are many different estimators that you could take this basic idea and this basic insight to. You could do maximum likelihood by looking at the likelihood that your utility vector, given the parameters, maps into any of those regions. There are Bayesian approaches that are very popular in the marketing literature. The maximum score estimator dating back to the 1980s. More recently, there have been developments with moment inequality methods and popular methods which allow for certain types of endogeneity as well to be used in a method of moments-based approach. You're probably familiar with the logit functional form in the case where epsilon ij has the extreme value type 1 distribution, where you say that the probability that agent i's most preferred option is j is given by the ratio of the exponent of xij beta for the option that the agent picked over the sum of the exponents of all available options. So this revealed preference picture resulted in this particular likelihood function. Now, what we're going to do next is to look at the rank ordered data case, where an agent has listed several different choices in order of some kind of preferences that they might have, and think about how you might engage in a very similar exercise. I will start with the non-strategic choice case before moving on to the strategic choice case, and tell you a little bit about the limitations of this approach and the key empirical findings that we have found so far. So let's talk about the non-strategic choice case. This case is the case where, for example, Al mentioned, you might have a mechanism in which it's the dominant strategy to report your preferences truthfully. What I mean by that is that it is in your interest to rank your most preferred option at the first choice, at the first slot, your second most preferred option at the second slot, and so on. Now, let's say that agents understand this, and they indeed behave in this fashion. Going back to our previous picture, where you have, say, two options, V1 and V2, option 1 and option 2, and a potential rank order list that you could write down, you now have a split of this same region based on the rank order list that you observed. An agent that ranked 1 and then ranked 2 indicates that this agent's utility lies in the region that says rank 1 bigger than 2. It indicates that 1 is better than 2 and that 2 is better than nothing. So V2 is positive. So this was a finer partition of the utility space that was revealed by this agent. And you can use this to go ahead and estimate your model. So here I've got the logit model, but now I've got a random coefficient beta I on this agent's utility for xij. So in the logit case where epsilon ij is, this is called a mixed logit case, sorry, epsilon ij has an extreme value type 1 distribution. The probability that an agent ranks j followed by j prime is given by this exploded logit form, where you first have the expression that indicates the probability that option j is the most preferred choice. And then you have the probability that option j prime is the most preferred, ignoring option j. So in the denominator in the second term, I've got k not equal to j. Because of the IIA property in the logit case, it boils down to the simple expression. If your functional forms were different, the likelihood would look a little bit different because it would just be the likelihood of being in one of those regions. But nonetheless, those other functional forms are typically also estimable. Now, when you have multiple choices, it gives you a lot of information about these random coefficients beta I. These are idiosyncratic preferences of agents for various options. So an agent, for example, who might like schools that are very big, or schools that have has a good student-to-teacher ratio, might rank these schools at the top, many of these schools at the top of the list, at the cost of other schools that might have more extracurricular activities or other features that might be attractive to other students. So by looking at the correlation between their top-ranked choices, the characteristics of the top-ranked choices, you can learn about these random coefficients. And this ordered data turns out to be very important and very useful in characterizing the heterogeneity in preferences for various school characteristics. And there are several papers now that have documented patterns in which there is significant preference heterogeneity along socioeconomic characteristics as well as unobserved characteristics of agents. So here are some estimates from my paper with Attila and Parag on preferences for 9th grade schooling programs in New York City. I've got various different specifications, and there are select coefficients here. The first two columns do not have any random coefficients. The second column has some observable characteristics. And the next three columns take robustness to later ranked choices seriously. Suppose, for instance, your 10th ranked choice is not as well informed as your first few ranked choices. And what you see is that you see very intuitive patterns, whereby, I'm sorry, it's a little bit small, but students that performed well in 8th grade in math seem to have a differentially strong preference for schools that have good math achievement outcomes. These are correlates and descriptive of preferences rather than causal, to be interpreted as causal estimates in which which indicate what would happen if you increased the achievement of a school. On the right-hand bottom, I've got a block of estimates that show you the random coefficients. And you'll see that these are very precisely estimated. And this is because in New York City, students rank up to 12 choices, and therefore you can learn a lot about their idiosyncratic preferences and the extent to which there's unobserved heterogeneity in preferences. So that was fairly straightforward because students were telling you the truth. What would happen if you had a mechanism in which students had some incentives to misreport their preferences? As Parag mentioned, in the immediate acceptance mechanism, which was used in Boston and is still widely used, for better or for worse, students are prioritized at higher rank choices. So some students might rank a school first, not because they like it, but because they would like to gain priority at this otherwise competitive school, or might want to cash in on their priority at this school. So from a student's perspective, there's a trade-off between gaining priority at their true second choice or ranking their true first choice first and taking a risk that they do not get assigned. So if you put yourself in the student's shoes, a student should be trading off getting into their most preferred choice with some small probability. If you really like it, if you really like your first choice, even though there's a small probability of getting in, you might as well rank it because it's worthwhile. If you're not so crazy about your first choice and you're roughly indifferent between your first and second choice, ranking your second choice first might guarantee you a position there, and that might be a better decision. Okay? So I'll discuss the baseline case in which agents make optimal choices, and not all agents might be fully sophisticated, but there are various approaches in this literature that allow for cases where there are biased beliefs or a mixture of naive agents and sophisticated agents, and other approaches that also place somewhat less restrictive assumption on the knowledge of the students on what they know. But it's instructive to think about the baseline case of fully rational behavior in order to think about how you might engage in this reveal preference type of exercise when agents are making strategic decisions. So here I've got a picture in which I have three illustrative rank order lists, or three illustrative reports, R, R prime, and R double prime. The horizontal axis is the probability of getting assigned to school 1. The vertical axis is the probability of getting assigned to school 2 as a function of each of these reports, R, R prime, and R double prime. Now, the vector V shows you the direction of the indirect utility of a given student. And the student has indifference curves that are linear, given by those dashed lines, increasing to the northeast. So this agent would likely choose either R or R double prime because that is the one that is going to maximize the expected utility. So if you look at all agents that ranked school R, these agents reveal that their indirect utility must be in this shaded region, must be pointing in the shaded region. Why is that? Well, if this agent's indirect utility vector was pointing to the left, to your left, then this agent would prefer increasing the probability of getting into school 2 at the cost of, and would not like a high probability of getting into school 1, and would probably pick R prime, which is the lottery to the northwest. If the agent's indirect utility vector was pointing down, that is, this agent does not prefer school 2, then this agent would be picking R double prime. So the lines here are the pivotal indifference curves that make R optimal, and the shaded region tells you all parts of the utility space, all directions in the utility space that make this choice optimal. Now, going on to R prime and R double prime, you can engage in a similar comparison, and you can figure out what their indirect utilities must look like. Now, moving on to the utility space, our familiar picture, you see again V1 and V2, and I've labeled three regions: CR, CR prime, and CR double prime. These three regions correspond to the regions where report R prime, and report R double prime are optimal. So R might be rank school 1 first and rank school 2 second. R prime might be only rank school 1, and R double prime might be only rank school 2. So again, you can take this picture and this partition, And what you can do is write down your likelihood function or your choice probability. And then you can go back to your favorite method, method of moments, simulate maximum likelihood, or any of the other ones that I had in one of my slides earlier. And you can use your techniques to proceed with analysis. You can also have some mixture models in which there are some naive agents that report truthfully and some sophisticated agents that behave like this. That will just give you a mixture of two likelihoods. So this kind of an approach has been used by several papers at this point. And I would like to show you that it's important to think about this form of strategic behavior. Since we're in Cambridge, and since I have a paper on it, here I've given you various schools in the Cambridge elementary school system, the public school system, placed in order of how many schools ranked it first. Graham and Parks is the most popular school. And you can see the top left number shows you that for a paid lunch student, even if the student ranked it first, there's only a 22% chance that this student is going to get assigned to Graham and Parks. A few rows down, you've got Fletcher Maynard, which is not such a good school. And if you're a paid lunch kid and you ranked it first, it's a sure shot that you're going to get in.
How do you know it's not a good school?
If you look at the outcomes and you look at the region where it is located, you would probably know that it's not a good school.
I would just know the kind of kids that live in that.
Sure. So in the next two sets of columns, I've got estimates of how desirable these schools are in terms of willingness to travel. So in terms of how many miles a typical student is willing to travel in order to avoid getting into Fletcher Maynard. It suggests that Fletcher Maynard agents are willing to travel 1.3 miles in order to avoid getting into Fletcher Maynard as opposed to the average school in the Cambridge public school system. And likewise, Graham and Park seems to be desirable since agents are willing to travel 1.3 miles in order to go to Graham and Parks. Now, if you instead assume that agents were sophisticated or had rational expectations about the probabilities of getting in, you would estimate that Graham and Parks is worth 1.9 instead of 1.3. And Fletcher Maynard is actually negative 2.3 instead of negative 1.3. So why did I get this result? Well, the students that rank Graham and Parks first are not only indicating that they like Graham and Parks, but they're indicating that they're willing to take a small probability, a 1 in 5 chance of getting into Graham and Parks, in order to, and therefore they indicate that they have a strong preference for Graham and Parks. Likewise, students are not ranking Fletcher Maynard, even though it's a sure shot, and therefore their willingness to rank other schools instead indicates that Fletcher Maynard must be particularly undesirable. So let me move on to some empirical findings and limitations of this approach, since it is not a silver bullet. Some of the findings that we found is, as I mentioned, significant preference heterogeneity for various schooling options based on socioeconomic characteristics. We found that coordinating admissions and assignments is of primary importance as it limits inefficiencies, since many students would otherwise be placed at unranked choices. Al mentioned the congestion that New York City public schools faced, where about 1 in 3 students were not placed to one of the options that they ranked before the reform, and this results in significant inefficiencies that a centralized system can solve. The immediate acceptance algorithm seems to have some benefits in terms of screening students that have a strong preference for a particular school and placing them at those schools. However, this particular finding depends on students really understanding how the mechanism works and having rational expectations about how competitive various schools are. Without very, very sophisticated students, these benefits are somewhat limited, and at any rate, these benefits come at the cost of assignments that are somewhat are not stable. There are some limitations here as well. These models take strong stances on parent information. If you want to interpret these estimates in terms of welfare, you need to make the assumption that students understand and parents understand what the various schools, what the characteristics of the various schools are, and what's good for them, and they're making choices in their own interests, in their best interests. Peer effects are largely ignored, since we only look at the value of assignment of your own value of your own assignment, rather than other students that might be going to school with you, and in that sense, Josh might be saying that if many students from that neighborhood go, I'm going to pick that up as, and those students are not so great, and I value my classmates, value the composition of schools, classmates in my school. Perhaps I'm picking up that I won't have good classmates instead of the teachers aren't very good. There's limited evidence on the monetary value for better schools, and part of that is a data constraint, since public schools in the United States do not charge tuition typically. And so it would be good to have estimates of the monetary value for better schools. And there's also limited evidence on the downstream effects of assignment on various achievement outcomes. So that was the relatively nicer case where you had information on some form of stated preferences, whether they're truthful or strategic. But in some cases, in many cases, you might have only information on employer-employee match data. So you might know what types of workers are sorted into what types of jobs and what they are paid, but you might not know exactly what their rank order list was over the various job options. Perhaps nobody collected it, or perhaps there's a centralized system that does allocate workers to schools, but that centralized system wasn't willing to share the data. In these data sets, you often do have information on various characteristics of the workers as well as the firms. Perhaps salary, other measures of amenities, the prestige of the job, the qualifications of the worker, the education of the worker. And you typically find that there's significant sorting in proxies for quality. So, for example, medical students that are trained at prestigious schools tend to train when they go to residency at prestigious programs and large hospitals. Now, you don't want to take this and straight away say that a resident that is matched at MGH prefers MGH to Brigham Women's, because it might have just been that Brigham Women's wasn't willing to hire this resident. And so you might want to work a little bit harder in order to think about what the preferences of agents might be. So you cannot directly use the data and interpret it in terms of reveal preferences approaches that I developed earlier. And second, you need a two-sided model for preferences, because as I alluded to, programs have preferences for residents as well. Now, the literature has typically used the pairwise stable equilibrium assumption, which tries to model a frictionless market in order to make some progress. As you've already learned, this equilibrium restricts the matches to satisfy two properties. First, no firm should be assigned more workers than it has capacity, and each worker has only one job. And second, no worker is placed prefers a firm that prefers that worker to a currently assigned worker. This is the no blocking condition that was introduced earlier. Now, substantiating this assumption requires some knowledge of market institutions. There are various types of failures that might occur in matching markets, congestion, unraveling being some of the ones that were faced by the medical residency market before it was centralized. So I'll talk about some of the estimates that I obtained in the market for family medicine residents using this equilibrium assumption, but this assumption could be used in other contexts when you're confident that market failures that would result in blocking pairs are not significant. So the key problem here is, how do you learn about preferences of both sides of the market by just observing final matches? So to build intuition, I will talk about a stylized canonical model in which the utility of agent I, worker I, for firm J is the same across all workers, and is given by some characteristics of the job, the wages or the salaries offered by the job, and some unobserved characteristics that might make the job desirable, captured by XCJ. Workers are going to be differentiated by the human capital of the worker, where xi alpha is the observable component, and there might be certain things like test scores or letters of recommendation that you do not have great data on, and so there are other determinants captured by epsilon I. In this model, whether there's transferable utility or not, you expect, and as long as in the transferable utility case you have a supermodular matching function, you expect to see positive assortative matching on U and H. The top worker gets his pick, and picks the top job. The median worker is left with the median job. And using this, I'm going to try to explain to you what you can learn from sorting patterns, which is what types of workers match with what types of firms, and why it might be useful to take advantage of the fact that typically many workers are matched to the same firm. Now, there's an additional issue, which is the wage endogeneity issue. I'm going to skip that for today. But with the control function approach, you can, with the availability of instruments, of course, you can deal with this wage endogeneity issue as well. There are many related papers that delve into the econometric issues and examine the transferable utility case and the imperfectly transferable utility case in the marriage market case and in the case of mergers and other applications as well that use similar equilibrium concepts. So let's say that you went to your data and you found that residents that are trained at high NIH-funded medical schools tend to match with large hospitals. So 30% of the matches are between high and large. 20% of the matches are between high and small. Then we have low and large at 20% and low and small at 20%. You can see some kind of positive assortative matching. And so you might be willing to say that residents at high NIH-funded medical schools tend to be better. They are not always better because there's this epsilon term that could be test scores that rearrange students across medical schools. But this suggests that large hospitals are preferable. However, you won't be able to look at this table and really tell me about the intensity of preferences for either large hospitals or high NIH-funded medical schools. And here's why. It could be that you're in a world where high NIH-funded medical students are always preferable to low NIH-funded medical students, and the test score doesn't really matter. So they go ahead, and whenever they pick the large hospitals with 60% of the time because there's something else about the hospitals that make them desirable. So you get this contingency table, this matching table. Alternatively, it could be the case that only 60% of the residents at high NIH-funded medical schools are better than residents at low NIH-funded medical schools. And so whenever they go ahead and pick, they would pick the large hospitals, and you end up with the exact same thing. So you can't tell whether this is driven, this imperfect positive assortative matching is driven because you don't observe everything about residents or everything about or everything about programs. Here's where it could be useful to have data from many-to-one matching. So you can ask the question whether residents that are matched at the same program, irrespective of the quality of the program, tend to be similar in their observable characteristics. So suppose you had everything, you had all observables that were relevant to a resident's quality. You'd be able to construct a very good index of this, very good aggregate of this resident's human capital index. And what you would find is that the variation within the program in this index, this observable index of human capital, would be extremely small. Why? Because within a program, within a small program, you expect that the residents are very similar. Otherwise, some resident could find a better job, or the program could find better residents in a pairwise stable match. And so what you can look at is whether this within program variation and see whether, and use that to figure out the program's preferences for the residents. If X strongly predicts human capital, then the within program variation is small. And if X does not strongly predict human capital, then the within program variation is large. And once you do this using the information available in many-to-one matching that is not available in one-to-one matching, what you have is you have the preferences of one side of the market, which allows you to roughly construct a choice set on the other side of the market and engage in a revealed preference style analysis. To show you how this manifests in the data, I've got the fraction of the variation in a resident characteristic that is within program. This is in the family medicine market. You can see that almost all of the variation in the gender of the resident, 96.4% of it, is within a program, which is consistent with the gender of the resident not being informative about the human capital index. You also see that the degree type, whether it's a foreign degree or not, a significant portion of the variation is across programs. So there are some programs with many foreign residents and other programs with fewer foreign residents. And so that is consistent with the case that foreign degree is informative of human capital. The most convenient method in this case turns out to be a similar to minimum distance estimator, where you take moments that are based on the overall sorting patterns, the extent to which you have assortative matching, and these within program variation moments, and find a parameter theta that determines the distribution of human capital index and the program's and the residence preferences that best matches these moments. So what can you do with this? Well, you can quantify value for various job amenities. In this case, you might want to interpret this as the value of training provided by various programs. So these estimates suggest that, for example, a resident is willing to take a salary cut of about $5,000 in order to train at a program associated with the hospital, the 1 standard deviation higher case mix index. Okay? Residents are willing to take salary cuts to train at the same state in which they were born or the same state in which they went to medical school. So these could manifest themselves in wages in terms of compensating differentials, for example. And one of the issues that came up with the medical match was that it was criticized as a direct and implicit mechanism for suppressing the wages of medical residents. There was a lawsuit in 2002 that claimed that the fact that medical residents make about $40,000 less than nurse practitioners or physician assistants is indicative of the fact that the match is causing this wage depression. And the reasoning in this lawsuit was based on a perfect competition benchmark, in which they said that substitute sources of labor that do the same thing should be paid the same wages. Now, there's been some debate about this, whether the match is responsible for this wage suppression. But we do not see, for example, in the gastroenterology fellowship market, that the presence of a match is related to the distribution of wages. This market transitioned from having a match to not having a match. There have been theoretical results as well on this question, and they've mostly resulted in somewhat ambiguous answers. So let me suggest to you that medical labor markets should be characterized, or better characterized, as markets in which there is imperfect competition amongst programs, and that could result in some degree of wage suppression. So what are the sources that you might have in mind? Well, there's accreditation requirements here which limit the number of residents each residency program can hire. There are fixed costs of operating, and there are certain economies of scale here. And programs are heterogeneous in quality. MGH, people are willing to take a salary cut in order to train at MGH, and it cannot hire all the residents that are available and would want to have a job there. So just simply these sources of imperfect competition could result in wage suppression. In fact, a very conservative bound on the effects of these sources of imperfect competition result in a $23,000 depression in wages relative to the marginal product of labor net of training costs. There are other sources. For example, simply the licensing might be valuable, and there's restricted entry into that could result in additional markdowns. And if programs are productive to heterogeneous levels, that also results in certain degrees of rent. But these particular sources of imperfect competition results in a lower bound of $23,000.
So does that tell us that $17,000 is upper bound on the shadow price of time
So if you're thinking about that as a cost of training, then this is a bound on top of this is a markdown relative to the marginal product of labor relative to the cost of training. So this does not speak to the value of the physician assistants, and in part, the salary of physician assistants, to some extent, Medicare and Medicaid reimburse programs for those costs of training. So it's a little bit hard to speak exactly to that particular bound. What this says is that these sources are responsible for $23,000, and additional things like just the value of the certification, the value of having a certification for practicing medicine might be responsible for some of this. And there might be other things like if programs are differentially able to produce with resident labor, those rents, those productivity rents will also accrue to the program. But I can tell you a little bit more about this offline. But this is supposed to be interpreted as marginal product of labor net of training costs. So if you think of net of marginal training costs. So if you think of physician assistant salary as a marginal training cost, it doesn't account for that. It's net of that. Okay? So it's different from the Beckerian human capital model. Now, these sources of imperfect competition are not directly related to the match and wouldn't necessarily go away if the match was not present, and therefore it's not as easy to conclude that the match is responsible for the majority of this or any of this depression. In addition, it's important to point out that centralized designs allow for ordered contracts and salary flexibility. Parag ran out of time, but I encourage you to look at his slides where towards the end he talks about how you might incorporate a labor market model within a centralized clearinghouse that allows for salaries to be set alongside the matching process. Now, this approach has been used in other contexts as well. This idea that you can restrict the final equilibrium outcomes in terms of either some notion of stability to recover something about the match surplus has been used in many different contexts. The venture capital context has been studied by Sorensen. There's a significant literature that studies marital surplus using pairwise stability. The efficiency of various market mechanisms have been also studied using these similar approaches, the value of mergers, and determinants of public school teacher matching. But in all of these approaches, including the one that I laid out, there are some kind of restrictive assumptions on preferences that need to be made. So for example, I said that residents are differentiated by human capital index. In other cases, you might have to bin agents into discrete groups based on the observable characteristics and map preferences accordingly. Or you might only be able to recover one single match surplus, as Sorensen does. So there are some restrictive assumptions required, and based on your application, you might want to pick one of these approaches. In all of this work, we have a richer matching function, but of course this is at a cost of having a frictionless market for either the labor market or the marriage market. And there's one recent paper that does incorporate some degree of friction in this marketplace. And so it'd be interesting to see if we can combine a rich matching function with some market frictions in future work. So in conclusion, I would like to say that it'd be interesting to think about what the effects of various market systems are on various outcomes that are intrinsically interesting for other reasons. These are important markets that are organized in these ways: education markets, health markets, and other high-stakes environments, marriage. And so it'd be interesting to think about how various systems result in other outcomes like achievement or mortality or other things of that form. A comparison with decentralized markets is somewhat limited so far, and that'd be interesting. But let me suggest that there are two features that I think are common that are present in these markets that are also present in many other markets that are characterized by rival goods that are non-excludable. In many of these cases, you have heterogeneity in the types of objects being allocated, the types of partnerships being formed, and there are capacity constraints. There are a few options of each type. In addition, there are also often limitations on the price mechanism, particularly when public goods are assigned, when publicly funded goods are allocated. There are a variety of other settings in which this occurs: course allocation mechanisms, public housing, organ allocation, allocation of medical care via wait lists, where you can see these two features at play. And in those cases, you might want to think about how the market works, the rules of the market, the available data, whether you have stated preferences or only final outcomes, in order to think about what the best way is to model the nature of the agent's decision problem to make progress on understanding what agent's preferences look like.